kind of the title of what we're doing here is we're going to use a circle of radius r to evaluate the trigonometric function. So our problem is this, and I'm going to state the problem, and I'm going to tell you what the issues are, and then we're going to, before we do this problem specifically, we're going to look at the generalities. So we have a point P, -10, -2, that's on the terminal side of an angle theta. Find the exact value of the 6 trigonometric functions. Now, the problem here, see, the problem is that we're not looking at a unit circle. This point P is not on a unit circle. So we cannot say, see, that tells us that the sine of theta is not -2. See, it's not the second coordinate. That only applies if that point's on the unit circle. Another issue here is we don't know what theta is. See, but we don't need to know. But let me point out to you, we don't, we're going to say the sine of theta is equal to, but we don't know what theta is. All we know about is some result of the angle theta. So here's more or less what we've got. Okay, here's more or less what we've got. We've got an angle, okay, theta, and -10, so let's assume, just so I have something to deal with, let's say that's where -10 is. This is not very precise. Whoops. And let's say this is where -2 is on the y-axis. So it's this point right here that is on the angle. So that means that the terminal side of the angle. So that means maybe the angle looks like that. But we can see already, that the unit circle would be a circle like this, wouldn't it? So there's no way that point is on the unit circle, is there? No way at all. And what we're needing to worry about, or maybe not, if we knew that point, then we could find out what the sine of the angle theta is. But that's not what we're dealing with. So let's first look at the bigger picture, the generality here. And let me redraw now. We're no longer thinking about the specifics of this point. Let me draw a situation where we have let's say we have a circle of radius r. Oops. So if I can do this, you'll bear with me. I know you've been good so far. I guess I don't know whether you're laughing or not, do I? Here's a unit circle. Okay, so this is the unit circle. And we've got a circle that is of radius r, so let me just, so I have something to refer to. So it would be out here at -r, wouldn't it? So the radius here is 1 unit. The radius here, this radius is r, okay, all the way across there. That's that radius. So we've got a unit circle, that's the inside circle, and here we have circle radius r. Okay, now let's suppose we have an angle. There's our angle theta. There's our angle theta. So what happens is that on this, we have a point, okay, that we know is on, and I'm kind of doing this backwards. We have a point that we know is on the terminal side of the angle theta. So we have a point, A comma B is the point, I'm going to call it. So all we really know is we have an angle theta, and we have an angle, and we have a point that is on the terminal side of that angle, AB. So what we really do is we draw a circle that goes through that point that is centered at the origin. That's what we do. So the equation of this circle that's centered at the origin is x squared plus y squared equal r squared in this case. It's r squared in this case, isn't it? Because the radius of that circle is r. Now, here's kind of the next issue that we've got then, is that when we're told, see up above, we're told a point that's on the circle, but we're not told what the radius is, or we're only told the point that's on the circle. But because the circle goes through the point, then we know the equation looks like this, and we ought to be able to use this to find r. How can we do that? Well, because we know the point that's on the circle. The x value is a, and the y value is b, and that's what r squared is equal to. So that tells us that r is the square root of the other side, a squared plus b squared. See, that's what that tells us. So if we know the point that's on the circle, then we know the circle of radius r goes through it, and so from that we can calculate the value of r. Okay, we can calculate that value of r. Now, let's look over here. Okay, let's look at this scenario. We've got this. We've got that. I'm going to drop a vertical. Okay, and so I'm going to refer to this triangle down here like this that I've just drawn. Okay, there's that triangle. Now, that triangle that I've drawn, right triangle, that triangle that I've drawn, this side is a units long, isn't it? That side is a units long. Excuse me, b units long. That's oh goodness, because that's the second coordinate. That's how high we are, isn't it? And this side is, if you will, besides the fact that this is negative, actually we should say it's the opposite of this as a length, but that represents that first coordinate, doesn't it? Now, this hypotenuse of this right triangle is going from the center to the edge of the circle, so this is r, isn't it? That's r. Now, let's consider this point that is on the unit circle, okay? And let's drop a vertical right there. Okay, let's drop a vertical right there. And so, just as reference, this would be, we'll say right here, okay? Now, what do we know about this distance? Remember, this is a unit circle, so this distance is 1. And the r is the distance here, isn't it? This big hypotenuse. This distance is 1. Now, this point, so let's see if I can come in here. This point's on the unit circle, isn't it? And so it has a first and second coordinate. Now here's the deal though. This is in reference to this angle theta. Remember, we're talking about this angle theta here. And so what we know is the first coordinate of this point is the cosine of that angle theta. So this is actually the cosine of theta, this first coordinate. And the second coordinate of that point is how we find the sine of theta. And so the second coordinate is actually the sine of theta, isn't it? Okay, so here's what we know. We know this distance right here is the sine of theta. And we know this distance right here is the cosine of theta. Okay? Well, get ready for the drum roll. Okay, get ready for the drum roll. Look, these two triangles are similar triangles, aren't they? These two triangles are similar triangles. And so in similar triangles, the ratio of the sides is equal. So let's look at, for instance, let's compare the side here, that's the cosine of theta, divided by, is the same to this side here, which is A. Okay. That distance is A. That's the same relationship if we look at the two hypotenuses. Hypotenuses. Well, the hypotenuse of the small triangle is 1 because it's on the unit circle. And the hypotenuse of the large triangle is R. And so when we solve this, that is, let's multiply both sides of this equation by A, the cosine of theta is equal to A over R. And remember, A is this x value, is this x value of the point that we know is on the terminal side. And the R is the value that we calculate right up here. Okay. Well, let's compare the side here to the side here. Well, the sine of theta divided by b, the relationship of those two sides, would be the same relationship as the corresponding side hypotenuses. And so in the small triangle, the hypotenuse is 1, and large triangle, the hypotenuse is r. And so that also, I'm kind of working backwards now, isn't multiply both sides by b, so the sine of theta, when I multiply both sides by b, is b over r. What's b? B is the second coordinate of the point we know, and r is the radius of that circle, but we can calculate r in this fashion. Oh my goodness. Well, let's go to the next page and summarize this, okay, real quickly. And so here's what we know. So the point AB is on the terminal side of angle theta. Well, what information do we get from that? Well, let's just draw back our little diagram. Okay. Now, we really don't need this so much as we've been used to, but here's our angle theta. We don't specifically know what that is. And we know this point is on the terminal side of theta, A comma B. Okay? And so there's a circle associated with it. And that circle has a radius R. Okay, that's the radius R. Now, the way we can calculate that radius we'll need in a moment. But okay, we'll need to be able to calculate that radius. But what we just saw on the previous page is that the cosine of that angle theta we just saw is A divided by R. Okay, so it's the first coordinate divided by the radius. And where we saw that the radius is calculated by using the square root of A squared plus B squared. And then we know from what we just saw on the previous page that the sine of theta, going through all that work, ended up being B over R. Okay, so B is the second coordinate of the point that we know that's on the terminal side. And of course, R is the radius of the circle that goes through that point. And we saw that we could calculate R by saying R is the square root of A squared plus B squared. Now, after we have that, if we wanted to know the tangent of theta, don't try to memorize a formula. We've already got one. The tangent of theta is the sine of theta divided by the cosine of theta. Now, we could come up with a formula and find out that that's actually B over A. But that's too much for us to try to memorize. Let's just remember, okay? Let's just remember how we calculate tangent generally. Okay, and remember that the way we calculate cotangent of an angle generally is the cosine of that angle divided by the sine of that angle. And let's remember, if we're calculating the secant of an angle, well, that's 1 over the cosine of the angle. Or if we're calculating the cosecant of an angle, that's 1 over the sine of that angle. So all we really need to do is remember how we deal with this part, and the rest of this stuff is old information. We don't need to reinvest. So now, here's what we've got. Okay, let's go back to our original problem. Our point is -10, -2. It lies on the terminal side, okay? It lies on the terminal side, on the terminal side of our angle theta. So we want to know what the sine of theta is, or the cosine of theta. Okay, the sine of theta. Well, the sine of theta from above is the second coordinate divided by r. Oh, well, we've got to figure out what r is. Okay, so we're going to come over here and we're going to figure out what r is. R is the square root of a squared plus b squared. And remember, a represents the first coordinate and b represents the second coordinate. So r is -10 squared plus -2 squared. So r is the square root of 100 plus 4. So r is the square root of 104. Now, we're going to keep this exact. We're not going to approximate that. Okay, we're not going to approximate that. Now, what we might look at is see if we can simplify it. So I'm going to look at 104 factors. Okay, well, certainly it's 2 times 52, isn't it? And 52 is 2 times 26, isn't it? And 26 is 2 times 13. And so when I look at this, really, I guess the best I can do is we really have a 4 times 26, don't we? So since r is the square root of 104, and 104 is 4 times 26, and I can't really do much more with 26, but the square root of 4 is 2. So r is 2 times the square root of 26, and the square root of 26 just has factors. 26 is factors 2 and 13, and we can't reduce anymore. Okay. So now we know the value of r. So we go back over here. B, that's the second coordinate, is -2. And r is 2 over the square root of 26. 2 times the square root of 26. And so now we see, oh, this is going to reduce because we have a 2 over 2, so this is -1 over the square root of 26. But we've got to rationalize that. So we'd say the sine of theta is -1 over square root of 26, and to rationalize, we need to multiply by square root of 26 here and square root of 26 here. And so we get a negative square root of 26 divided by 26. Okay? What about the cosine of theta? We don't know what theta is, but we know the point -10, -2 is on the terminal side of the angle. Well, what we went through above says, okay, you use the first coordinate, but you divide by the radius, r. Okay, and we found out what r is already. Well, the first coordinate is -10. And r is 2 times the square root of 26. And so now we just go to town on simplifying, okay? So we'd have -10 over 2. Oh, that simplifies to -5 over the square root of 26, doesn't it? And so we would need to rationalize again, and I'm just going to tell you when we do, we'll get -5 times square root of 26 divided by 26. And you can go through that rationalization. I don't think that's that big a deal. Okay, I'm not going to do all 6 trig functions because we kind of have an idea of what we would normally do anyway. But let's do the tangent of theta. Now, I'm not memorizing a brand new formula here. I'm going to say, oh, tangent of theta. That's the sine of theta divided by the cosine of theta. Now, there may be a quick way to do this, but I'm not telling you there's not another way. What I'm telling you is that you're going to be inundated by trying to memorize little special formulas, and I'm telling you that there's just some you need to memorize, okay? You don't need to memorize them all. But in this case, the sine of theta is negative square root of 26 divided by 26. And the cosine of theta is, negative 5 times the square root of 26 divided by 26. Now, when we, first thing, negative divided by negative is positive, isn't it? Okay, so we know that. And then when we do the multiply by the reciprocal, well, what we're dividing into is the square root of 26 divided by 26, and we're going to multiply that with the reciprocal of what we're dividing by. What we're dividing by is reciprocal is a 26 in the numerator and 5 times the square root of 26 in the denominator. Okay? Well, look what's going to happen. Square root of 26 is going to cancel square root of 26, 26 with 26, and so we get a result that's just 1 over 5, don't we? Okay, just 1 over 5. And we could do something similar for each of the other 6 trig functions, and of course you will be asked to do that. But you get the idea. What we needed to know was how we calculate sine and cosine, and how we calculate r, and then the other trig functions follow. I think that you can carry on from here.